All right, here are solutions for our fifth quiz for Math 211. The basic idea in this quiz, I guess there's a couple parts. This first part, you're testing the different properties we have. So you read through here and you're looking for the associative property of addition or the commutative property of addition or closure and so forth. So if you read through here, to calculate 57 plus 64 in my head, I did the following. Line 0, well, my answer must be a positive whole number. That is true because of the closure property. Technically, it's the closure property of whole numbers under addition. But if you just told me the closure property, frankly, I'm happy. Call that good. So what about between lines 2 and 3? Well, let's see. Then I said, all right, I got 57 plus 64, and I broke that up to 56 plus 1, which I then changed to 1 plus 56. So from line 2 to 3, all that changed is instead of 56 plus 1 here, I wrote 1 plus 56. That's the commutative property. Commutative property of addition, if we're being technical. And what the commutative property allows you to do is change the order that you write things. So 56 plus 1 is the same as 1 plus 56. Then between lines 3 and 4, well, in line 3, I have 1 plus 56 grouped. In line 4, I have 56 plus 64 grouped. So I wrote these three numbers in the same order. I just grouped them differently. The property that allows me to do that is what's called the associative property. Associative. And again, everything in this one will be of addition, because I only did addition in this example. And then lastly, it says between lines 5 and 6. Well, okay, so I got 1 plus 56 plus 64, and then instead of 56, I wrote it as 50 plus 6, and 64 is 60 plus 4. And then what I did is I changed the order here again. The 50 stays the same and the 4 stays the same, but the 6 and the 60 change place. The property that allows me to switch those places is what's called the commutative property. Again, just like it was above, and it's still of addition. And I guess that's all I got to do. I go through and finish the problem. I say 6 and 4 gives me this 10 here, and 110 and 10 gives me this 120, and I get the 121. But frankly, you don't care about all of that because you've answered all of the questions. Okay, so then you come down here, and you're asked to write a problem that is most naturally solved using each of the methods listed below and explain. Well, I'll leave maybe I'll talk through the explanation, but won't write it. Explain why the method you chose is most preferable. So the set model of addition, I have 2 something apples, fine, pretty generic, I'm not feeling creative. I have 2 apples, and you give me 3 more. How many do I have? And the reason I would use the set model of addition is kind of those tangible objects. You have 2 of them, and then you got 3 more of them. In total, you want to know how many you have. It makes sense to start out with a set of 2, and then another set of 3, and kind of mash them all together to get your set of 5. But I don't want to write all that, so I'll just say it. What about the measurement model? Measurement works well when you're talking about time or distance or something like that. Distance is the kind of typical example. I throw a ball 20 feet. 20 feet in some direction. Then I pick it up and throw it 5 more feet. How many feet has the ball traveled? And again, the measurement model where you start out with the number line and you kind of jump over to 20 because you threw the ball 20 feet. Then you pick it up from that 20 and throw it 5 more feet. So you can kind of think about starting at 20 and taking 5 steps to the right. Would be an easy way to model this problem. Distance, as I said, works well for the measurement model. What about the set model of subtraction? Okay, so there are 12 cookies on a plate. I take, I don't know, 5. I like cookies. How many are left? It's clearly subtraction. But the set model would work out well because you could model out 12 cookies. You could draw 12 cookies. Then you grab 5 of those things and remove them and figure out that there's 7 left. What about the measurement model of subtraction? Well, it's a lot like the measurement model of addition, where you're using the number line, except now we're going in the other direction. So, I don't know. I drive 10 miles to the store from home. Then run out of gas 4 miles from the store. How far am I from home? And yeah, you should probably put a couple qualifiers in there, like you ran out of gas 4 miles from the store on my way home, maybe. Something to that effect. But again, we're going to use the measurement model because you could think about a number line and driving to the store, which is over at the 10 on the number line, and then driving back at 4. So you haven't made it all the way home. You still have 6 more to go. Anyways. The missing addend approach. So the missing addend approach works when you have a subtraction problem that you think is easier to model with addition. So how about a toy costs $5. I've saved $3. How much more do I need to save to buy the toy? Essentially, it's asking me 3 plus what equals 5. It's a subtraction problem, but you can think about it in addition using the missing addend approach. And it would be a pretty natural fit in a problem like this where that's what the question is asking you. You have 3. How many more do you need? 3 plus what is it that equals 5? And I guess that's the end of this quiz. So I'll stop the video here.